All right, hello again, everyone. So we're just going to dive right in to talking about spring and summer phosphorus. Another hello if you just hopped on. My name is Kate Laramie. I'm a watershed ecologist with the Huron River Watershed Council and a newly appointed member of the CLMP management team. So excited to be here. So what is phosphorus and why do we care about it? Phosphorus is a very important nutrient. It's key to primary productivity or the growth of algae and plants. Phosphorus is also often the limiting nutrient in our freshwater inland lakes. So this means that without it, things couldn't grow. So it's really important to have around. But too much phosphorus can cause problems. And I'm sure many of you are aware of the types of problems I'm talking about. So we refer to extensive phosphorus loading, so the introduction of a lot of extra phosphorus as cultural eutrophication. So eutrophication, just as a reminder, is the process of additional nutrients being added to a lake or a river system that's causing more primary production. So you have a lot of nutrients going into that system and helping a lot of things to grow. And cultural eutrophication is when we have humans that are doing things on the landscape that are increasing the amount of nutrients that end up in our lakes. And this cultural eutrophication can have a lot of negative consequences. So higher algal biomass. So, I mean, there's a lovely picture of some very, very green water. So we have a lot of algae, a lot of nutrients in this lake that are allowing a lot of algae to grow. This can reduce aesthetics. It can reduce your economic value. And it can also lead to increase in anoxia, or in other words, a reduction in dissolved oxygen in water. We think of water as being, not associated with oxygen, but there is dissolved oxygen in water that's really critical for life. So might see fish kills or, animals that aren't able to survive because there's no more oxygen in that water. And then this can also increase the likelihood of HABs, harmful algal blooms. So not all algae is toxic, but some of it can be. So a really classic example is harmful algal blooms that we've seen in the last several decades in the western basin of Lake Erie. So this is an image from space. This is a satellite image of the western end of Lake Erie, down by Detroit, Maumee, Toledo. And these are algal blooms that we can see from space. And these are mostly due to really intense cultural eutrophication that has been going on in this Great Lake for many, many years. And some of this algae can produce toxins, and that's when we then call it a harmful algal bloom. So a toxin-producing algal bloom that can pose a lot of really dangerous health risks to people and animals. So many of you probably heard of algal bloom that happened in the early or in the mid kind of 2010s when the city of Toledo, Ohio actually had to shut down their water intake. So they had to cut off water supply to the entire city because there was the risk of that harmful algae getting into their water systems and causing a lot of health impacts for folks. So there are going to be some really big economic and human health consequences of this cultural eutrophication that we're seeing in many of our lakes across the country and across the globe. So how do we use phosphorus to calculate trophic status? So again, trophic status being the amount of nutrients that are in our lake that helps us understand how much growth can happen there of algae and plants. This is a table that just shows very directly our values. That center column that says TP, that's total phosphorus, either in parts per billion, which is a very small measurement, or in micrograms per liter, also a very small measurement. So it can be measured in different ways, but essentially we're looking at all of the phosphorus in that system and what is the concentration of that value. So if we have less than 10 micrograms per liter of total phosphorus, that's an oligotrophic system. So a system with very clear water. There's oxygen likely throughout the entire part of the water column where we have life. And then down all the way to a hypereutrophic system, we have greater than 50 micrograms per liter of total phosphorus, and we have a lot of really intense algae blooms that are probably happening in that system. In the column to the left here, we have our Carlson's TSI. That's that value that I reviewed in the SecuDisc presentation that you would get in your lake monitoring report, that kind of blue to green bar graph that shows, how eutrophic is your system. And this value is calculated by using several different monitoring parameters, one of which is total phosphorus, another of which is SecuDisc, which we already talked about, to help us understand how eutrophic is our system, how much nutrients are in that system. So you can see on a oligotrophic system, the Carlson's TSI would be less than 38. That's the value. Versus on our hypereutrophic end, it'd be greater than 61. So those are values that are in your report that we help you understand to get a better understanding of what ecological conditions are happening in your lake. So here's another slide that demonstrates basically everything that I just said, but we're thinking about the trophic status, so how productive is the lake, how many nutrients are in that system, and then, how much plant and animal life can the lake support. And the indicators we're really looking at here to calculate that value are transparency, or SecuDisc, total phosphorus, and chlorophyll A. So if you monitor any of these parameters, we'll be able to calculate your Carlson's TSI and give you a sense for what the trophic status is in your lake. If you monitor all of these parameters or two of the three, we'll take some averages of those values to give you a more robust number and better understanding of our trophic status. So spring and summer phosphorus. So we measure at the CLMP, we take a single sample, so a single bottle of water. I'll talk about how we do that in a minute, in the spring and in the summer. So these are two separate monitoring parameters that you can sign up for. However, they are monitoring the same thing, the concentration of phosphorus in your lake. And we monitor them separately for reasons that I'm going to get into in a minute. But this is what that would look like in your lake report. On that summary page, you would have spring phosphorus recorded on its own graph with its own summaries of how many samples were taken, the average values of those samples. And then similarly for summer phosphorus, you can see here on the right. So why do we collect in spring and summer? So lakes have during different periods of the year, they are going to be stratified or mixed. So I'm going to talk through what that means. So in the springtime, we have a very mixed lake. So that means that all of our water is all mixed together. It's all, around the same, very similar temperature, and it's all kind of mixed up. In the summer, we start to have stratification happening. So basically what that means is we have the water's heating up at the top of the lake, and that water, that higher temperature water is starting to float on top of our cooler temperature water. And though we're developing these really clear bands called, these more fancy terms are epilimnion, metalimnion, and hypolimnion. You don't need to remember those words, but just, think of it as you're swimming out in your lake and, you're in deep water and you let your legs kind of hang down. So you're just swimming with your arms. And if you've ever experienced that feeling where your feet are really cold and your upper part of your body is really warm, that's because you've just punched down through that epilimnion and you've hit that stratification layer. And as humans, we're heavy enough that we can move through that layer very easily, but that different density of water causes it to separate out throughout the summer season. And then in the fall, our lake starts to mix again. The water on the top is cooling. It's starting to flip over with the water on the bottom of our lake. And then in winter, it's a little bit more complicated, but we start to see a little bit of stratification happening in a different way in the winter that I won't delve into because we don't do monitoring in the wintertime. But if you're really interested in lake ecology, Eric or I, but definitely probably Eric would be very happy to chat with you about all of these dynamics more intensively. So why do we sample in the spring? That's because we really want to understand what phosphorus is looking like in our lake overall. So remember, our spring lake is very well mixed. That water is all mixed up. It's not stratified. So by taking our sample, we're able to get a representative understanding of what phosphorus is like in the system as a whole. This also helps us understand how phosphorus can build up in a system over time. So when we talk about, you'll see in a few slides how we actually sample for phosphorus, but we're just sticking a bottle in off the edge of our boat a couple feet below the surface and taking our water sample. So by sampling in the spring, knowing that that top layer of water is going to be very similar to the water that's mixed throughout the whole lake is really important because that tells us something different than when we sample in the summer. So our summer sample, our lake is stratified. So we have that warm water on top, our cooler water below. So what our summer phosphorus sample is able to tell us really what's going on in that epilimnion, that top part of the water column, rather than the whole lake. And this really helps us understand summer algae growth because that epilimnion is the area where there's a lot of light that's able to get through the water. And what algae and plants need to grow, they need light. So by understanding what phosphorus, how much phosphorus is in that top layer of the water column, we're really able to get a sense for what productivity may look like in that lake. And this is the value that we use to calculate trophic status. So if you sample spring and summer phosphorus, they're going to help you understand, more about your lake. However, only that summer sample is going to go into calculating that trophic status value that helps us understand, is our lake oligotrophic, eutrophic, mesotrophic. High summer phosphorus values can also indicate external loading issues. So this is really, additional nutrients that are coming into the lake from the landscape, often in the form of fertilizer. You're fertilizing your lawn right next to the lake. It's running off into your lake, and we can capture that in the epilimnion measurement. Other types of loading, there may be upstream a stream coming into your lake system, and there's additional nutrients going into that stream that then end up in your lake. So this summer sample really tells us a lot about that trophic status and productivity in our lake, and whether we're seeing issues with that cultural, like external loading happening. So how do we collect our phosphorus sample? Well, first off, you're going to get a bunch of things in the mail if you signed up for to monitor phosphorus. So you're going to get a packet that includes monitoring instructions, a schedule of when you need to sample and when you need to turn in those samples, which we'll talk a lot more about in a minute. Your data form, so the paper that you actually need to write the information on when you collect your data. You're going to get bottle labels. So we're going to collect this water in bottles that we send you. So we send you labels to put on those bottles. And then the bottles themselves, you're going to get a couple bottles because we want to take 2 samples so that we have our primary sample and our replicate, which is just an identical sample. So we test them both and make sure that they look similar. So you're going to get all this information in the mail. And then you're going to need to also supply some material on your own. So you'll have to bring a cooler bag with you, or a cooler onto your boat. An ice pack, we really recommend those hard, solid ice packs that just live in your freezer rather than ice that melts and gets messy. But a cooler bag, an ice pack, Ziploc baggies of different sizes, and a pencil and a Sharpie. You'll need those materials. You'll need to provide those materials on your own. So spring phosphorus is measured during spring mixing. So how we want to identify when that is we're looking at monitoring 14 days after ice out. So we have missed this monitoring period for most lakes in lower Michigan, at least. So 14 days after ice out, within that period is when we want to be going out and taking our spring phosphorus sample. You determine when ice out is. So it's really important to write this down on your data sheet. We've had some really great questions over the years about what happens if we have an early ice out and then the lake freezes again. We had this happen several years ago with some really wacky weather that was going on. If you need help figuring out when ice out is, or you have very specific questions about your lake, please get a hold of me or Eric. We can help you figure this out. It can be subjective and challenging, so we're just going to do the best that we can. We are getting a surface grab sample, so that just means we're putting our bottle down onto the surface of the lake. We're not diving down into the lake. We're not sending our sample bottle somehow, magically into the depths. We're just taking the water from the top of the lake. And once again, that's really going to represent what phosphorus is doing in that whole lake, because the lake hasn't stratified yet. And this can help us understand whether nutrient enrichment, so the total phosphorus in that lake, is really increasing over time versus whether we're seeing maybe increases just during certain seasons. Our summer phosphorus sampled is measured during that summer stratification period. So we really want to wait until the end of the summer when our lake is fully heated up and fully stratified. So that's going to be between August and September, depending on your latitude. So this is not the same date range for every lake in Michigan. Michigan's very tall. We have a lot of latitudes in the state, so our northern lakes are going to monitor at a different time than more of our southern lakes. So we'll talk more about that sampling schedule on the next slide. Once again, you're going to take a surface grab sample, so it looks identical to your spring monitoring protocol. And then just to reiterate, this is really helping us to understand what phosphorus is available for things to grow during the growing season. This value is also used to calculate that trophic status, as I mentioned. All right, so when do we sample? So for spring phosphorus, as I said, that's going to be within 14 days of ice out. So it's going to vary for lakes across the state. You're going to note that date on your data sheet, and then everyone is going to turn in their spring phosphorus samples on June 30th to different turn-in locations based on where your lake is located. So we've really tried to spread these locations out across the state. This is just a screenshot of part of the turn-in page. There are many more locations, and this is all listed by county of what county your lake is in. That helps you identify where you need to turn your sample in. So for instance, Washtenaw County, that's an easy one because it's by itself. You would turn your sample in to me at the Huron River Watershed Council in Ann Arbor. So take a look at your sampling drop-off location. UP lakes for phosphorus, you're going to sample in the summer, as I mentioned, towards the end of August versus the southern counties, you're going to be sampling at the end of September. So for summer phosphorus, your sampling periods are going to range also, but obviously they're not linked to ice out. Okay, so how do we actually collect these data? Step one, you're going to fill out your labels. So these are the labels that go on your sample bottles, and you're going to fill them out before you go out on the water. It is very hard to stick labels to wet bottles, so we recommend filling these out in your house before you get on your boat. You can use a pencil. I prefer a permanent marker just because it's a little bit easier to see. Make sure you use a fine tip permanent marker because chunky ones, these are really small labels, so you wouldn't be able to read them. You're going to label, you're going to make 2 labels, one for each of your bottles, and on one of your labels, you're going to include REP, which stands for replicate. So that's your replicate sample, just to sanity check. In science, we always like to take more than one sample just to make sure that there wasn't an issue with our monitoring parameter with our monitoring protocol or something odd happening with just that one sample. So you're going to fill out your labels, and then you're going to get out on the lake, and you're going to drift your boat over the deepest part of the lake. So if you were here for the Secchi presentation, it's the same thing. You're going to have that deepest part marked. We're going to help you identify where the deepest part of your lake is. And then you're going to get to that deepest part of your lake. And the first thing you're going to do is you're going to take the cap off your phosphorus bottle, and you're going to rinse it twice. So you're going to stick it into the water, fill it up, swish it around, dump it out. You're going to do that 2 times. And then once you've rinsed your bottle, then we can take our sample. We want to make sure that we're rinsing it. These are sterile bottles, but just to make sure that all the stuff in that bottle is from that lake, and there's nothing else there that could contaminate our samples. Really important, only use the bottles we provide, and make sure that you don't contaminate that bottle or the cap of the bottle. And really, contamination is just sticking your hands in it or something else in it. So just keep that cap and bottle clean and only touching your lake water. So then you're going to go ahead and collect your sample. So once you've rinsed it out, you're going to hold the bottle upside down. You're going to lower it into the water 1 to 2 feet. As far as you can, as far as you can go, down to 2 feet. If you have shorter arms like me, it might be more like a foot, foot and a half. And then you're going to turn that bottle upwards so that it fills with water. And then you're going to repeat that with the second bottle. I'm going to show a video at the end of the presentation that demonstrates this, and I think makes it a little bit more clear. Once we have our bottle filled, this is really important. We're going to pour out a little bit of water at the top of our bottle so that the bottle is only about 75% full. This is because we're going to freeze our samples. So if it's full all the way to the top, our bottle will crack and that sample will be contaminated and we won't be able to do anything with it. So once we've poured out a little bit of water, we're going to put our bottles into our cooler with our ice pack. And we're going to place those bottles in a labeled baggie. So we always just want to label everything, keeping everything together in those Ziploc bags. Our data sheet that we're going to fill out goes in its own bag, and then that bag goes into the bag with the sample. So we want our data sheet in our own bag, in its own bag, so that it doesn't get wet and gross. But again, just making sure that we're labeling everything, keeping everything together in those bags. This is what our data sheet looks like. I'm not going to go through all of these things that we want you to write down, but I will note, just make sure that you're noting your weather conditions, whether there's unusual conditions, just like with the Secchi parameter, whether there was heavy rain, boating, things like that happening on your lake. Really important that you obviously identify your lake name, county, township, your field ID. And then if you're doing, in this case, this is a spring phosphorus data sheet, you've got your date of ice out, which is really important for us to know to process your data. This is what the back of your data sheet is going to look like. Just like the Secchi data sheet, we ask you to draw a map of your lake and identify the point at which you were sampling, just to sanity check that you were basically in the right place, that you weren't sampling some other lake or some other area of the lake. So you're going to get back to shore and you're going to take your samples out of your cooler and you're going to stick them in a freezer until it's time to turn your samples in. So this is not a good parameter to go out and take your sample and then hang out on your lake for a few hours. We really want to get those samples back in the freezer as soon as they're collected. All right, and then you're going to turn your frozen bottle with those data forms that have been nicely packaged in all those plastic bags into your designated location. So make sure you're looking at that drop-off location and time in the phosphorus schedule that we will send you in the mail, but it's also available on the MiCorps website. And if you have any questions or confusion, please email us so that we can make sure that you're getting your samples to the right spot and not missing any of the deadlines. Common reasons that we reject samples. So just some things we want you all to be aware of. If you collect your sample at the wrong time. So if you're doing spring phosphorus and you collect your sample more than 2 weeks after ice off, you can still collect it as long as it's less than 4 weeks after ice off. So we want you to collect within 2 weeks after ice out. If it's between 2 and 4 weeks, we will still take it, but we're going to flag your sample just in case there's an error. And if it's been more than 4 weeks since ice out, we can't take your sample. It's just not the same data. Summer phosphorus, if your samples are collected more than a week outside of the assigned interval. So as I said earlier, you're only collecting one sample. You're only going out once to monitor this parameter, and we give you a time period based on your latitude is when we want you to collect this sample. And if it's more than a week outside of that period, we can't take your sample. If you forget or can't turn in your samples to the drop-off location on the assigned date, that can cause some issues. So if you know that that's going to be an issue for you, please contact us and we'll figure out how to get the sample to us. Some folks ship their samples to us, but if they're not done properly, they can thaw in the mail and then we won't be able to use them. And then again, making sure that you're not overfilling your bottles because if they crack in the freezer, we have to get rid of them. And once again, only use the bottles that we are providing to you. We will not accept bottles or containers of any kind that are not the bottles we send you. So I'm not gonna talk much about this slide, just again, re-emphasizing the value of long-term data. The more that you monitor this parameter, the more we can understand how nutrients are changing or not changing in your lake over time. Really important just to try to keep monitoring if you're able to, so that we can then say something about the trends and changes, potential changes in lake health. All right, so I am going to show about a 5-minute video that's going to show you everything that I just talked through, which I think is really helpful for this parameter.
Hi, my name is Tamara Lipsey, and I'm an aquatic biologist with the Michigan Department of Environment, Great Lakes, and Energy. Today, we're going to demonstrate how to take a phosphorus sample using the MiCorps Cooperative Lake Monitoring Program procedure. Phosphorus is an essential nutrient for plant and algae growth in lakes. In the Cooperative Lakes Monitoring Program, phosphorus is sampled in the spring, after ice out, and in the summer in August or September. Before heading out on your lake, please assemble the necessary equipment. You will need your 2 sample bottles that are provided by MiCorps, your labels, a pen and a permanent marker, your data sheet, a map of your lake, a cooler and ice pack, your safety equipment, and an anchor in case it's windy. Make sure you fill out your bottle labels and attach them to the bottles. It's very hard to write on bottles once they are wet. Let's take a look at what a correctly filled out sample label looks like. Please use a fine-tipped permanent black marker to fill out the sample labels. You will fill out your initials, the date, the lake name, and the lake ID number. In addition, write GA for parameter code. Leave the chemicals added area blank. You will do the same for the second sample label, but you will also write REP next to the lake name. This is short for replicate. Fill out the top of your data sheet and the map of the lake on the back of the data sheet. Next, proceed to your monitoring location, which should be over the deepest part of the lake. If you need to anchor, make sure you drop your anchor before the deepest location and then drift to your sample site. This will ensure you do not collect any sediments that might be suspended from the anchor. Once over the deepest location, unscrew the bottle and make sure to never touch the inside of the cap or bottle. Then rinse the bottle with lake water twice. Now grab the bottle around the base. Turn the bottle upside down and lower it into the lake about 1 foot below the surface. Tip the bottle upward to fill the bottle. Bring the bottle back up to the surface and spill out a small amount of the water so that the bottle is only 3/4 full. This will ensure the bottle will not crack when you freeze the sample. Store the bottle in your cooler with an ice pack and then collect your replicate sample the same way you collected your first. Once you're done with the replicate sample, store the bottles in the dark cooler with frozen ice pack and return to shore. Once you return to shore, you will need to freeze the water samples immediately. The samples go into a zip top bag with your lake name, county, and field ID number. Fold the data sheet, place it into a separate zip top bag so it stays dry, and place that in the bag with your samples. Storing your data sheet with the samples is a good way to make sure the paperwork never gets lost. Once you're done, store your samples in the freezer. On your designated turn-in date, deliver your frozen phosphorus samples and data sheet to the proper turn-in location. To learn more about the MiCorps Cooperative Lakes Monitoring Program, visit us at micorps.net.
All right. So with that, I think we've only got about a minute, but Joe, were there any questions in the chat or anything we wanted to address now?
Thanks, Kate. There was one question that came in privately. They were asking, they said they hadn't received their summer phosphorus bottles yet, and they were wondering when they would get those.
Yeah, good question. They should be there soon. So Eric, I don't know if you wanted to chime in. I know you had just done a bunch of mailing and sent things out for folks.
That's right. We send our materials in waves. And so if you had signed up for spring phosphorus, you got those late winter, early spring. And then we have sent out most other materials that you've signed up for, except for summer phosphorus. So summer phosphorus, because the sampling doesn't take place until for the UP starting in August, we send them later in summer. So hang tight. You'll be receiving these in June, July, and you'll be ready to go.
Great. Thanks, Eric, for that clarification.
And then one other question that came in, if there is a collection site closer to our home than the one listed for our county, can we arrange to drop it off at an alternate location? For example, some of our Livingston County lakes are quite close to Ann Arbor.
So the answer is generally yes. However, it depends on whether the sampling drop-off date is in the same is the same as that additional drop-off location. So, Eric, I don't know if you want, I know that Livingston and Washington in particular, you and Tamara flagged, but generally I would say if you message Eric or I, we can work things out. We just want to know ahead of time. But Eric, do you
Yes.
want to chime in on that?
The important thing is it's more of so if you can work with different drop-off locations, but on the schedule that we provide to you in the mail and then also on our website, it's your sampling dates that you need to stay in. So Livingston County has a different sampling date set than Washtenaw. So please follow the sampling dates for yours and then work with Kate, because she's the drop-off location in charge of Washtenaw, to make sure that she knows that you're coming for that. So, but make sure you are sampling during your scheduled sampling time.
Great. Thanks, Eric. Thanks for that clarification. Yeah, and as always, if you have a particular situation, whether it's different location, issues with time period, questions about ice out, anything like that, we want to work with you as much as possible. Just make sure that you let us know so that we can get you the right information and we're not missing anything along the way.